Good afternoon to all of us here from a group of 13. Our topic is the study of stochastic local search algorithm multi-objective optimization problem for itinerary recommendation system. In the overview, we will discuss four things: introduction, analysis, design, and implementation. Introduction. Search background. In general, every tourist wants an interesting and satisfying tour so that they need an optimal travel itinerary. Tourists have restrictions on travel such as cost, time, distance to travel. This variable makes this problem a multi-objective optimization problem. Based on the use of the variable taken into consideration, we will conduct a study entitled "A Study of Stochastic Local Search Algorithm on Multi-Objective Optimization Problem for Itinerary Recommendation System." This is purpose. The purpose of this study is to determine a more optimal stochastic local search algorithm for the travel itinerary and how to model the constraint satisfaction problem to be solved with a stochastic local search. Scope. The scope has two is variable and dataset. Variable. The variable used are the distance, cost required, travel time, and review of tourist attraction or rating. Dataset. The dataset used is a collection of data that has attribute of distance, cost, travel time, and review of tourist attraction or rating.
Data analysis. The data used in this study was obtained from Google Maps by Scrapple. Data obtained from Google Maps are longitude, latitude, tourist restriction, and rating. We use Google Maps because Google Maps provides data that is in accordance with the variable needed. So, this is our data. Travel route dataset. Estimation method. Estimation distance. To get estimation distance, we have formula Habersin. So this is the formula Habersin. How to get jarak, and this is the explanation and the other explanation of the all attributes. Estimation cost. The formula is total cost is bus rental plus full, and full is the formula, and this is the explanation our all attribute formula. And we have estimation time. To get estimation time, so this is the formula where this is the explanation. Analysis data preparation. We use three stages in preparation data. Data cleaning. In data cleaning, perform to clean data by filling in blank value using the fill the missing value manually technique on several attributes, and overcoming inconsistent data and null drop to ignore or delete data subject. Oh no, delete that object. The second, data integration. Integration of aims to combine data from different data sources. And the third is data transformation. The technique that we apply is attribute feature or feature contraction which will from a new attribute from an existing attributes. Analysis of the objective function. Fitness function distance. To get distance fitness value from each itinerary, following criteria are needed. The A, assuming the user enters the number of tourist attractions that he wants to visit. B, its fitness value distance is not equal to 0. It may not move. C, the distance of each itinerary is added up to get the total distance needed. So this is the equation used is where S is distance between tourist attraction, I is itinerary. The next fitness function, cost. To get the cost fitness value of each itinerary, the following criteria are needed. Is total cost must be not zero. In this case, it does not go anywhere. B. The cost of each itinerary is added up to get the total cost for the trip. C. Minimum cost do not guarantee that the itinerary will a minimum cost is fitness value. D. Maximum cost do not guarantee that the itinerary will maximum cost is a fitness value. Fitness value is obtained. Next is fitness value is obtained if the total cost obtained is accordance with the user input, but if there is no match between the total cost of the itinerary with no total input cost, then it will use local optimality. Next, local optimal is obtained from the lowest cost range. The authors apply the optimum minimum because the total input cost will affect change the total input cost when using the maximum. Optimal maximum. So this is our question where O is total cost incurred by the system, total EI is total cost entered by user and is itinerary. Fitness function. The next is fitness function time. To get the fitness function time of its itinerary, the following steps are required. A is travel times when there is not more than 12 hours considered several ultra tourist spots that have sunset spot and several of things. The time B is the time for each itinerary candidate is sums based on the number of tourist attractions the user want to visit. C is total times on the itinerary candidate is close to the total time entered by user. So this is a equation where x total expanded by the system, y is time taken by the user, n is itinerary fitness function, and the last is fitness function rating. To get the fitness function value of itinerary, the following criteria are needed. A is rating of visitors attraction will be added. B is the total rating is divided by number of tourist attraction visited. C is the average rating result into the fitness function for ratings. The equation is that whereas rating of a tourist attraction, so S is more 0 and not more 5, and its number of tourist attraction. This is the algorithm. We have two algorithms, but we only one implementation in this proceeding. Simulate annealing. Simulate annealing is algorithm for optimal that function generally based on probabilities and statistical machine. This algorithm can be used to find solution to optimal global solution. And the other algorithms. Metric and method evaluation analysis. We use satisfaction evaluation. We analyze the level of user satisfaction with the itinerary provided, compare itinerary produced by the system with the itinerary designed by a travel agency. Algorithm performance evaluation. We use multi-objective optimization or MORA method because it's able to solve for those types of problem considering all the criteria used with a simple and easy to understand concept. So this is the step. The first input criteria, the second is make a decision matrix, and the third normalization, the MORA method. The fourth is reduce the value of maximal and minimal, and the fifth is determinant ranking of the result of the MORA calculation.
Design. System architecture design. To build a system, we use Django. Django is a Python-based web framework that supports creating fast development websites with elegant designs. Some libraries that we use in data mergence, data preparation, and library implementation are Beautiful Shop library, NumPy library, Pandas library, library itertools, and library GA. The itertools library used to facilitate the implementation of the iter local search algorithm. Library GA is used to implementation of the evolution algorithms, while the technique used is the genetic algorithm. And the next, data preparation design. Collect data, we use some steps, namely, first we determine supporting hypotheses to help analyze data. Then determine the variables or data attributes as needed. And the next step is to scrape data from Google Maps using a scraper. We use the scraper extension on Google Maps. The next, data cleaning design. In cleaning up the data, we identify data that is empty or incomplete. If it is complete, then the process is complete. If it is incomplete, then we fill it using the technique to manually fill in the missing value, namely the fill backward function and the fill forward function. After that, we check again, and if there is still incomplete, we use the ignore tuple method, which is the incomplete installation line. And the next, data integration design. To overcome the data release is not necessary. We do the analysis on the dataset. Variables that will discuss the name of the tourist attraction. Data that has a high conversation will be reduced using the function drop provided in the Pandas library. And the next, data transformation design. The dataset used contains the names of the tourist attraction, longitude, latitude, and rating. The first stage is generating a tourist attraction, then building new attributes, namely distance using the Haversian formula, time attribute using the GLB formula, and cost attribute by considering view and bus travel rental. And the next is optimization design. The assistance system is needed, such as the system of time and cost needed by tourists. Then the system will do the optimization. Then the system will make more optimal schedule decisions. The decisions is then given to tourists as a recommendation. And the next, the last, experimental design. Before entering the algorithm, the data must be encoded to recover the search during algorithm implementation. The next stage determines the fitness function as a standard schedule that will be generated. Then the implementation SR, ALS, and AR. The result of the implementation will be described. The algorithm will produce up to 150 solutions. The solution will be evaluated using the Mora method, and the resulting itinerary is more optimal.
Implementation. Library. This is the library that we use in implementation our tugas akhir. Loading the data. df sama dengan pd.read. It is useful for reading file using the Pandas library. pre_ta_13.csv is naming our data. Print banyak data sama dengan len_df to produce how much data. Output. A lot of data is 606. Generate tempat wisata. This is function takes the names of tourist spot from the data frame. When generate, there is a random function that the library already has. For e in rank to 10. Rank as a random function. Rank to 10, meaning randomization to 10 tourist attraction. The set of tourist attraction to be chosen, for example 7. X is a tourist attraction chosen from the data frame. It will be accommodated with tourist attraction. Encoding. Encoding function, there are two parameters. One, itinerary, two, tempat wisata. This function has two looping iteration. One for X in rank len tempat wisata, two for Y in rank len itinerary. For X in rank len tempat wisata, until the length of the tourist data, the state will check Boolean. The check will be true and false, so the check is the same as false. For E in rank len itinerary, this will check whether the itinerary is available or not at the tourist site. If there is, then 1 is stored in array, and if it is not there, then store 0 in array.
I'll continue our demo presentation. Fitness function. In fitness function, we find two class. This is pre-itinerary and the other class fitness function. In pre-itinerary, we find get function get long length. In function get long length, we parsing param. Param is encoding from itinerary. So in function, we'll return test where test is array to save latitude and longitude from data. And next is function generate get rating. Like get long length, param is encoded from itinerary. Rate is array to save rating we get from data. So we'll return rate. In the other class, we have function Habersin, estimate waktu, estimate biaya, and average rating. In Habersin formula, we have formula in slide presentation. So this is will return of this. This is calculate of distance from one place to the other place in itinerary. The next is estimation waktu. Estimation waktu will parsing jarak. Jarak is calculate distance from Habersin formula. So waktu is jarak divided v, where v is 60 default reference velocity, and returns time horse, where time horse is this is waktu. And the next is estimate biaya. Estimate biaya, we parsing waktu, so waktu get from estimate waktu, and you have default there BBM as BBM. BBM is bahan bakar minyak, and bus jarak tempuh and the other, so total cost is biaya BBM plus biaya rental is return total cost. And the next function is average rating. Average rating is pre-process rating. Pre-process ratings like uh, parsing we get from class pre-itinerary. So we call this function to get this value will parse. F is null, average is null, so this is looking to get all total rating in itinerary. So average is float will divide and of pre-process rating and total average. So we'll return average. How to implementation? So we must set input, where input is parsing param to get input data in implementation, so we get implementation well. This is temp data is data frame tempat wisata. Only one attribute we can temp in temp data. Itinerary is generate itinerary tempat wisata, so call function in top our presentation. So paste per itinerary is the class, encode is encoding itinerary parameters is to get this is function get two parameters. The first is param and the second is temp data. And so pre-process itinerary to get one is p is class pre-itinerary to call class pre-itinerary. So this is the function, and this is the parameters encode is from there. And next is pre-processing rating is base. Yes, it's same like get longlet. VA is class fitness function. How to call the data function in fitness call fitness function like that. Jarak is VA in formula preprocess itinerary preprocess. We get there, and waktu jarak is from here, and biaya waktu from here, and rate is F is class average rating. Preprocess rating is in the other class we call function get rating, and input will save and fitness function. Our fitness function jarak, waktu, biaya, and rate. And the next we'll continue my friends.
Implementation simulate annealing. Simulate annealing has four components. There are initial temperature, final temperature, cooling rate or decrease, and iteration rules. Simply put, the concept of simulate annealing is like a blacksmith. Heat iron, then knock until the iron cools again. Iron that is hot from the final temperature. If the final temperature is higher than the initial temperature, it will continue to be beaten and consideration a degree of cooling until the iron is cold and the initial temperature. We built a class that is CML, which is holds three functions: the test function, calculate function, and solution function. This function is to test the function to get parameters. a new place for storage containing input and itinerary. It holds the function of generating tourist place. This function takes the name of the tourist extraction from our data frame. And the next, calculate function. This function is used to choose a solution with two parameters, namely x1 and x2, which hold for example to itinerary. If the zero index itinerary in parameters 1 is smaller than the zero index in parameters x2 and the 0 and 3 index itinerary in parameters 1, then the 0 is smaller than the 0 and 3 index itinerary in parameters x2, then return x1, and apart from that return x2. And the next, solution function. T_akhir is a final temperature that we default to 500. T_awal is the initial temperature lower than the final temperature, and we default to 0.0001. Then our cooling rate defaults to 0.9. If the initial temperature is lower than the final temperature, then it is a solution and stored directly into temp case. But if the initial temperature is higher than the final temperature, then the final temperature must be multiplied by cooling rate until the initial temperature becomes lower than the final temperature. To display all solution, we create a class that contains the result function to display the final function. Namely class print. The final solution is 147 itinerary by displaying distance, time, cost, and rating, and average rating of each itinerary.